So, phototransistors. You will need to use phototransistors, and so we cannot leave today until you have learned what you need to do, the lab. So, buckle yourselves in, folks, because here we go. All right, phototransistors are NPN BJTs. The difference being, from your standpoint, that they don't have any base lead. Instead of a base lead and base current, they have light that falls onto the base. And that light serves the same effect or the same purpose as base current would for an ordinary NPN transistor. Phototransistors are the only kind of transistors that we will use both as saturated switches and in the linear region. Okay? We will use them as sensors, and we will condition the signal so that we can treat it as an analog voltage. So as basically, if you pick a collector emitter voltage drop, and it works best if you hold the collector emitter voltage drop constant, that will give you the most linear response. As you increase the amount of light that's falling onto the base of the transistor, it will increase the amount of collector current that flows. So that's the basic functionality. They look just like LEDs. In fact, that's why we don't buy the water clear versions. We buy the versions that are smoked or gray looking. That's an infrared filter because these phototransistors are all sensitive in the infrared. Near infrared, but still not the visible spectrum. The smoked package makes it easy to tell which one is the IR phototransistor, and it also eliminates the slight sensitivity that they do have in the visible spectrum. Package-wise, they look just like an LED, except that they use a flat rather than a notch to indicate the polarity of the two pins. And let me get it straight. Oh, they've got it here. So here's one. That's the emitter. So the emitter is the long lead, and the collector is the lead that's closest to the flat. Be careful with polarity on these things. They do exhibit a much reduced, but still there, light sensitivity even when they're in the circuit backwards. Okay, so if you don't seem to be getting the response out of the device that you expect in terms of current flow and voltages, check to make sure that you've got the device in backwards, or not got the device in backwards, because it will still respond to the light coming on and going off even when it's in the circuit backwards. All right. What you're going to be interested in mostly is looking at the on-state collector current. And there's quite a range between, we want to look at the 3208E because that's the one with the smoke package. And there's still a 2-to-1 ratio between typical and guaranteed minimum current flows. So these things are not particularly well qualified in terms of the current to light transfer ratio, what the magnitude of that relationship is. What is very well qualified is that it's a highly linear relationship if you will hold the collector emitter voltage constant. So what you're going to be looking for is a circuit that will allow you to hold the collector emitter voltage constant. One other thing that you should be aware of, they can be driven into saturation. If you are not holding the voltage across them constant with some external circuit, which I'm going to show you momentarily, then it is possible to drive them into saturation, and when they do that, they end up with a saturation voltage that's a bit higher than you would expect by our rules of thumb. Just be aware of that. Yes? The EE is the amount of light that is falling on the device. 5 milliwatts per square centimeter is an irradiance specification, so the amount of light falling onto the sensor. All right.